I live about 4 hours from here in upstate New York, and I trained in New York City in my residency and fellowship when I was actually on faculty for a while. And when I was in New York, people thought that anything that was called upstate New York was just north of maybe Poughkeepsie, and there was this vast wasteland. With a lot of tundra, by the way. But that's really not true. I live in the westernmost lake, which is Canandaigua Lake. This is the lake we overlook. And there are actually more than 5 Finger Lakes, but 5 key ones. And what's really interesting is that over the last several years, there has been an explosion of wineries. This is just showing you, this is Canandaigua Lake from a different view, the grapes growing there in the fall. And this shows you on the lakes how many wineries there now are. So it's really proliferated. And what's really interesting is that some of the folks that are buying up the wineries in the Finger Lakes region are coming from the West Coast. And there's real concerns about global warming up in the Napa Valley, and my daughter actually works at one of the vineyards there. And so we're seeing a really great increase in the number of wineries. Now I live over in Canandaigua, as I mentioned to you, which is way over here in the west. I live actually right there. What's interesting, there's not a lot of wineries there, but we're now known for something different. And that is something called Constellation Brands. I don't know how many are aware of this, but a wine company started in Canandaigua in 1945, and they were known for Manischewitz, and then Wild Irish Rose, actually, which I got to know in my internship in my residency at Bellevue for obvious reasons. But lo and behold, this company really started to get their act together in the around 2000, and they have grown incredibly rapidly, and they are now the largest wine company in the world. Constellation Brands owns a number of key wineries throughout the world, and this is just showing you some of the wines that they own. Large among these are Mondavi, Ruffino, Nobilo in New Zealand, in Australia, the Kim wine over here, and they actually have they have a number of wineries in Sonoma and Napa as well. And they've also more recently gotten into the beer market. So they've been the major importer of Corona for a very long time, and they've not recently bought up craft beers. Ballast Point in San Diego, you may know, they paid $1 billion for that company 2 years ago, and they've now in acquisition of many craft beers. Why, you might ask, would they be interested in buying craft beers? Well, every time that Donald Trump goes after Mexico, their stock drops rapidly. And so this has been a major problem for them, obviously, in being the major importer of Corona. So Lenny, next time you come to upstate New York, I know you like red wine, but we'll drink some great Riesling. Some of our Rieslings are really fantastic. Not quite Mosel, but very high quality. That's upstate New York. So what I want to do this morning for you is to talk about the challenge. As Elaine mentioned, when we started in this field, particularly me, I'm older than she is, nobody was looking at psoriatic arthritis. We now know that there's great interest, primarily because we understand the disease more completely and we have a lot of treatment options. With that development of new agents, we have a much better idea of what the mechanisms are that underlie SpA, some of which I'll review for you this morning. And then I'm going to talk about where the field is moving in bugs, fat, and bone. Talk about emerging therapies that are coming, that are right off stage, but moving rapidly. This field is very, very moving forward at an incredible pace. And then other treatment considerations to think about when you have a patient with spondyloarthritis, either psoriatic arthritis or axial SpA. So the challenges, what are the challenges that we face with these diseases? Well, first of all, we're not doing as well as we think we are. This is from a telephone survey that is the MAPP survey carried out in households in Canada, the United States, and Europe. And you can see that about 21% of patients in this survey had psoriasis. The first 3 bars are the different stages of psoriasis in terms of severity, mild, moderate, severe, and the last column is psoriatic arthritis. And what you notice from this survey is very depressing. and that is the majority of patients, even with severe psoriasis or with psoriatic arthritis, forget about being on any kind of systemic therapy. Many are on no treatment or on topical agents for their psoriasis and nothing for their arthritis or for their more severe psoriasis. So this is telling us that there's out in the population, there's a large percentage of patients that remain what we would consider to be inadequately treated. We also know, and these are from a number of studies I'm showing here for you, that if you look in dermatology offices and you send a rheumatologist into that office to examine patients with known psoriasis, that about 15%, that's the sort of point estimate taking all these together, of patients will have undiagnosed PSA in derm offices, and you can see the ranges are quite wide. So we really are struggling and are working very hard. Elaine is one of the leaders in this area to develop strategies to help our dermatologists identify patients with inflammatory arthritis earlier. And believe me, this is no small chore. It's very challenging. The average time that a dermatologist spends with a patient is about 4 minutes. So to try and get the joint elements into the history is something that we're working around the dermatologists in their offices. So the other, moving over to ankylosing spondylitis or axial SpA, this has been another area that over the last decade has incredibly changed, and that is the notion that we don't necessarily rely only on radiographic changes of the New York criteria, but that there's this whole other population out there, more common in females, that have inflammatory back pain, who may have HLA-B27 and other features, or have imaging elements that would indicate they have sacroiliitis or spinal involvement. And there's a big debate in the literature, as you know, about whether or not there's a relationship between non-radiographic SpA and ankylosing spondylitis. And in this very great editorial that Atul Deodar and I think Vipika was involved with, they sort of point out that this is actually a spectrum. And I think that the evidence today would point out that that's the case, that these related disorders. What is apparent, though, is that if you follow patients with non-radiographic axial SpA over time, and we're out to about 4 years in most of the studies, a very small percentage of those patients with non-radiographic axial SpA develop ankylosing spondylitis, which is comforting, although if you look at the data on how those patients are doing in terms of pain and function, they're similar to what we see in radiographic AS with damage, and that's a major challenge for us. So drug development in psoriatic arthritis and SpA has been amazing. During my fellowship in the early 90s, late 80s, we had very limited choices. The decade after that was dominated by anti-TNF therapies, which really were incredibly amazing from the point of view of treatment responses that we'd never seen before. We then moved into the IL-12/23 area with ustekinumab, apremilast, the oral PDE4 inhibitor, and now we're into the IL-17 and 23 universe, as well as other approaches I'll talk about briefly. So there's been a really great advance in terms of our therapeutic options, and it's incredibly exciting for those of us and you who take care of these patients. Anti-TNF therapy is clear. We know there's 5 agents out there. We know that there are ACR 20, 50, 70 responses. The trial designs are all very similar, overlap. We know that this soluble receptor is not quite as effective for the skin as the antibodies, and responses of ACR 70s that are in the 60 to 70% range, which is at the time was really a transformative actually. Remember methotrexate, the PASI 75 is about 30%, so this was double what we were seeing with the commonly used treatment for psoriasis at the time. But here's our challenge as rheumatologists right here. So if you look at the efficacy of IL-23 blockade with an antibody to P19, and right now I don't care what company's making it, all these responses are amazing. I'm just showing you one example. This is our early phase 1 trial in Nature giving 3 injections of an anti-IL-23 antibody, and you can see where these injections are given by the arrows, and you're looking at the PASI response, and this is the duration. So what's really incredible is that after 3 injections and then no drug, you're seeing responses in the skin that are lasting out, extremely strong responses, out up to a year. So is it possible that one agent will be effective for psoriasis? Maybe. This is really quite incredible, and it was unexpected. Despite the fact that IL-23 appeared to be important in animal models and in human disease, I don't think anyone expected this kind of a result. What about, we know that in psoriatic arthritis, I showed you the data, in ankylosing spondylitis, you look at anti-TNF agents, excuse me, the ACE-20 is about 50%, the BASDI is about 50%, so there's major unmet need here that we'll be talking about shortly. So there's work to be done. So what about the mechanistic landscape? Well, there's many ways of looking at this, and this is just one way, is looking at pathway enrichment. So you perform study on blood cells or tissue. This study is on blood cells, and you ask the question, which pathways are enriched in ankylosing spondylitis compared to other diseases that may or may not be related? And what you're seeing here is the red clusters are genes that are only expressed in AS. On the top are genes that are only expressed in Crohn's disease, ulcerative colitis, psoriasis, type 1 diabetes, celiac disease, RA, multiple sclerosis, and primary biliary cirrhosis. And this area in here is the overlap with AS. And you can see that these diseases on the top have pretty strong overlap in terms of the shared disease pathways with ankylosing spondylitis. Not surprising, inflammatory bowel disease, psoriasis, type 1 diabetes I might not have expected, but perhaps this may be very important, and I'll get to in a bit, and that's this overlap between metabolic and immunologic pathways, which is now becoming much more apparent as we gain more knowledge. We also know, work from Oliver Fitzgerald and my former mentor Bob Winchester at Columbia, that if you look at MHC haplotypes, they may give you insight into subphenotypes. So here we're looking at a cohort of patients, about 250 or so, of psoriasis and psoriatic arthritis patients and controls, and looking at their MHC profiles. And what you see is that what we know very well is that psoriasis, the major gene, a risk factor, is CO602 or CW6. Very similar in its magnitude to the shared epitope in rheumatoid arthritis, very dominant in the genetic architecture for risk here. Another gene that pops up is HLA-B08, which is also seen enriched in patients with psoriatic arthritis. Notice that PSA patients have B27, not seen in psoriasis. They also have B39, and their CO602 is considerably lower. So the impact of risk of CO602 in psoriatic arthritis is not nearly as great as it is in psoriasis, although it's higher than we see in patients that are in controls. So again, B08 is enriched compared to controls, B27 is enriched, and B39 we don't see at all in either group. So Oliver and his group in Dublin, and in collaboration with Bob Winchester at Columbia, started to look at and correlate this with phenotypes. And what they showed was certain MHC haplotypes were linked to certain phenotypes. So joint deformities and ankylosis, and you can see the haplotype, extended haplotype, dactylitis, and enthesitis. Well, this is very exciting because we've all been trying to understand what it is that drives these subphenotypes from a mechanistic point of view. Why does a patient get dactylitis? Why does a patient get enthesitis? Why do they get axial disease and psoriatic arthritis? So perhaps additional work in this area with more advanced techniques will provide some insights into that long-asked question that we're struggling with. So last month, Daphne, myself, and Bob Colbert tried to capture the pathogenesis of psoriatic arthritis in this review. And the way that we view this is that probably the sentinel events of the disease begin in the skin. And this is largely driven initially by an interferon alpha signal, very similar to what you see in lupus, driving plasmacytoid dendritic cells to make alpha interferon, and then generation of a Th1 and Th17 response in the draining lymph nodes, which then return and drive this IL-17, 23, IL-22 keratinocyte proliferation and phenotype that we see in the skin. The next question, though, is the critical one, and we're still struggling with that. what is it that happens in 30% of psoriasis patients or so that leads to psoriatic arthritis? Is it that there's a spillover of cells from the skin that go into the joint and into the enthesis? Or indeed, is it that most patients with psoriasis actually have subclinical enthesial and bone involvement, and there is a lack of suppression in those patients that develop arthritis? And we're working very hard to sort through both of those mechanisms, but at this point, we're not clear. We do know, and I'll show you in a moment, that there's a variety of cells that are released into the circulation in patients with PSA and ink-spawn, then that become enriched in the joint and drive the inflammatory response. And that inflammatory response, at the center of this is TNF and IL-17, IL-23. We know that there's osteoclast precursors that are released from the bone marrow into the blood and travel to the joint, at least in psoriatic arthritis. And then we know that there's a whole biology related to enthesitis, which is driven, we believe, by biomechanical factors, as well as altered cell populations in the enthesis that are probably driven by IL-23. So this is the current pathogenesis as we now know. As you can see, there are many holes and many areas we need yet to fill in. So the main T cell subsets, just to review, in SpA are Th1, 17, and 22. This is an advance that's been made over the last 10 years, and obviously therapies we now have are very focused on either these subsets or their products. So the other area that I just wanted to briefly highlight is an area that a lot of us are very interested in immunology in general, but particularly in SpA, and that is the innate lymphocyte subset. There are 3 of them, and I'm just taking you through this just to, if you're not familiar with it, I think it's an important area to think about. And that is, there's a common lymphocyte progenitor shown on the top. To the left is the thymocyte and the root that we all know about, which is Th1, Th2, Th17, Th1 gamma interferon, 2 IL-4, 5, 13, Th17, IL-17. But there's also a common innate lymphocyte progenitor shown over here, which leads to the production of the NK cells we all know, but then also to 3 innate lymphocytes, 1, 2, and 3 subsets, and think of them as analogous to their products to the adaptive T cells. So ILC1 produces gamma interferon, 2 IL-4, 5, and 3 IL-17. Rho gamma T is its transcription factor. And why am I bringing this up? Well, because these cells are really early responders in mucosal surfaces. So they're seen early in psoriasis in the skin, they're seen early in Crohn's disease in the gut, and it turns out that they may be very important in spondyloarthritis. So there are now data which have come from 2 studies I'm going to review very briefly, showing the importance of the TC17 cells, CD8 positive 17 producing T cell and innate lymphocytes. So this is a work that was published by Bruce Kirkham's group in London, and they asked the question, if you look in the synovial fluid of patients with psoriatic arthritis versus RA, and you look for non-Th17, so non-CD4 IL-17 producing cells, what do you see? And there's mainly 2 key observations. One is that these subsets are low in the blood and high in the synovial fluid in PSA, CD4 negative, CD8 positive, whereas in RA, didn't really see them in either the peripheral blood or in the synovial fluid. Moreover, the frequency of this population correlated with their DAS28 CRP score with their ultrasound findings. The second study I wanted to show you was one looking at innate lymphocytes. So here you have, looking at this population I just told you about, 1, 2, and 3, gamma interferon, IL-4, 5, and IL-17, and looking at healthy controls, psoriasis, PSA synovial fluid, PSA peripheral blood. And you can see, once again, these cells are enriched in the synovial fluid, particularly ILC3. Both ILC1 is enriched in both RA and PSA. Then when you go look at a subset of this ILC3 population, shown over here, and this is a population that has high IL-23 receptor expression, and you can see that these cells are enriched in the psoriatic versus RA synovial fluid, and then when you look at the IL-17 production by these cells, it's shown to be higher in psoriatic arthritis than rheumatoid arthritis. So it appears that the cells that are making IL-17 are not just restricted to Th17 CD4 cells, but also TC17 CD8, ILC type 3, and also there's a variety of other gamma delta T cell populations of which there's a lot of interest coming in new publications, one in ANR about a month ago, showing that the gamma delta T cell populations enriched in SpA and that these cells make IL-17. So, the other area that's been a lot of interest in our field has been the synovial enthesial complex, both in psoriatic arthritis and axial SpA. Obviously, this is the peripheral enthesis. The central enthesis in the spine involves the bone and the entheses, which join them together. An excellent review was written on this most recently by Michael Weissman in ANR in talking about some of this biology. But the basic element that we're all focusing on here is the fact that the enthesis is more than just a tendon inserting onto bone, but has a lot of adjacent structures that are subject to biomechanical stress and on the production of danger signals. And the danger signals, we believe, are probably coming from the synovial tissue and the bursal tissue that are adjacent to this tendon, which is under biomechanical stress. And for some reason, perhaps with the right genetic background that I just talked about, then this stress results in danger signal responses and an inflammatory phenotype. Whether this is the initiating site of inflammation in the spondyloarthropathies is a source of much controversy. There are studies on both sides of this using imaging. I won't go into this because I think it's still very unclear, but it's a very interesting area. The study that really tried to bring this into the animal model world, which it had not been before, we didn't know whether or not enthesitis was important in animal models. I'm not going to spend a lot of time on this. Ian McInnes and Rick Lorries drew this diagram. It's from Jonathan Sherlock's paper in Nature Med, a great paper from many different viewpoints in terms of the way they took the approach to answer the question. And I'm just going to tell you the bottom line if you don't know it already, and that is that mice do get enthesitis. This is a passive collagen-induced transfer model. The enthesitis is driven by interleukin 23, and they did some very clever experiments to figure out what cells were expressing the IL-23 receptor in this mouse model, and it was a very unusual cell type at that time, not so much now, very similar to what I've just told you. CD3 positive, 4 and 8 negative, and expressing the IL-17 transcription factor. So this is thought to be a native cell population in the enthesis, also in the aortic valve and in the uveal tract. Very interesting. So when they did some very interesting experiments, fascinating actually, using minicircle that contain IL-22 or 23 and 17 in these mouse models, they found that IL-22 is responsible for osteoproliferation using transcriptome assays and inflammation, whereas IL-17 was driving bone loss and TNF. So this is really fascinating because it explains in one pathway the phenotype we see in our office, which is patients that present with erosion and new bone formation, that present with enthesitis and axial disease. There's the confirmatory work regarding the role of IL-22 in bone formation is still very controversial. Recent paper published from Dennis McGonigal showed in vitro he could show that IL-22 did drive mesenchymal cells toward bone. We have a number of experiments in this area, and I can just tell you the work is ongoing. It's very interesting. I think there's going to be a role for IL-22 in pathologic new bone formation. How big that role is remains to be determined. So just to confirm what I just told you, there are a number of animal models, all shown here, in which you can take a mouse model, different strains as you see, manipulate them in various ways, trauma, fungal products, dectin, curdlan, or crossing them different kinds of models that overexpress STAT3. And you can see they develop very many features that are seen in spondyloarthritis. And what's most interesting is that in every one of these models you can block it with IL-23. So it appears that mechanistically IL-23 is driving a lot of what we're seeing, at least in the animal model. And I wouldn't be surprised in humans as well. So I'm going to turn now to bugs, fat, and bone. I can go on about the microbiome here for a very long time. 4 years ago, Jose Scher, 2 years ago, gave a great talk in his work at NYU in psoriatic arthritis and RA. I'm just going to highlight one study you may not have seen before, and this is published by the group in Australia, led by Matt Brown. And now, obviously, the N is small, and that's concerning, but nonetheless, I think the findings are intriguing. So they looked in the stool of patients with AS versus controls, and they showed that in the 9 AS patients, they had an abundance of these Bacteroides species here, and also firmicutes that compared to controls, and they showed using this principal component analysis a difference, and as well here. Probably more relevant is a paper published in January in A&R by the group in Dirk Elwelt's group in Belgium, and they actually showed when they went in and did ileocolonoscopy and they looked at the lesions that were in the patients with AS, no bowel symptoms, any of these patients, and you know there's very high prevalence of bowel lesions in these patients without symptoms. They found there was an overabundance of a species called dilaster in the specimens that were chronic but not acute. So I think this field's emerging. What really is important to know is the metabolomics. In other words, what are the functional consequences of having these different kinds of bugs in there? Do they overproduce amino acids or other products that are driving a specific immune response? And I think the science of metabolomics is moving along pretty quickly, and I think hopefully we'll have some of those answers soon to know whether or not we should be giving our patients probiotics or altering their bowel flora. So there's a number of risk factors for psoriatic arthritis you know about, so I'm switching back to this transition. Probably one of the ones that I've been most interested in and totally not been able to understand is obesity. So obesity is a major risk factor for the development of psoriasis or the development of psoriatic arthritis. And there's a number of really high quality population studies that have shown this. Moreover, there's studies that are shown out of Italy that if you take patients with psoriatic arthritis and you get them to lose weight, that their responses to anti-TNF agents increases dramatically. So, what is this link? What's going on? How do we think about this mechanistically? And I think to date, it's been hard to sort this together, but I would highly recommend this review article for everyone in this room. It was published a couple of months ago from a very great investigator at Harvard. And basically what he portrays in this particular manuscript is that there are really amazing interactions between immune pathways and metabolic pathways. And he takes you right through from Drosophila to the human system, and he talks about the interaction in the liver. Our patients get fatty liver, adipose tissue. Over 50% of our patients have BMIs over 30. He talks about the pancreas, type 2 diabetes, and type 2 diabetes in particular, very elevated in PSA and psoriasis. And the brain, these patients have much higher rates of anxiety and depression. So how can we explain this? Are there metabolic, immunologic overlaps that may provide some insight? And in this paper, he really beautifully shows you that there are these overlap between interaction with innate cytokines, free fatty acids, insulin, etc. And these interactions occur at multiple levels. They occur at cell receptors, they occur at organelles, in signaling cascades, and also in transcription. And the four major signaling areas he focuses on in this overlap is IKK, JNK, and PKC. So we're now starting to understand more about this, and I think these kinds of insights and studies balanced around this with metabolomics and other approaches will help us understand why our patients have these really striking prevalence of metabolic abnormalities. So emerging therapies. So the problem with PSA in particular is we have to deal with so many different domains. And this is so frustrating because you may get 4 of them under control. And as you well know from your office practice, if one is very active, it can become a major problem for your patients and for you. We've been fortunate that the more recent therapies have really been directed at all these domains. We've been very lucky in that way and have been in some ways transformative. So let's talk about first targeting the IL-17 pathway. You're looking at the different forms of IL-17, A, AF, F, E, and C. And the targets so far in terms of secukinumab and ICSI have been focused on IL-17A and IL-17A when it's bound to F. But there is another agent I'm going to tell you about that actually interacts with both A and F that is now being studied and may have some importance in this disease. And that's called bimekizumab. This is a phase 1 study, very early. So obviously you have to take this with some grain of salt, if you will. But this is an antibody against A and F. This is looking at 4 doses. It's a phase 1b study. And, this ACR20 response is a home run in this small group of patients. You can see the ACR40 and the ACR20. And the skin responses were really quite amazing as well. Again, in a very small study, they had no safety signals, and a phase 2 trial is underway. So this may be a very interesting approach that may give us a higher response. Obviously, the problem here, or potential problem, is host defense and what effect it might have in terms of adverse events. We'll find that out shortly as they're recruiting for this study now. So the other important point to make, and this is actually from Philip's study sitting in the front here, is that there are divergent tissue responses in the skin and the joints. It just drives us crazy, actually. So this is brodalumab, an IL-17 receptor antibody, and this is showing you from Kim Papp's article, week 12, really very impressive PASI 75 response. This is Philip's study looking ACR20 at week 12, and we would all agree that these responses are not optimal. Now, this may have been too early in a time point in arthritis, but nonetheless, it shows you the different dynamics with the same agent used to treat the skin and the joints. And this is something we are all struggling with. So let's talk about ankylosing spondylitis for a moment. Unfortunately, we don't have a lot that I can talk to you about early pipeline. Ustekinumab, this is a phase 2 study that was published 2 or 3 years ago. And these responses are very striking. As you can see, an ACS20 of 75% is really impressive. Very small studies, 20 patients, but it provides proof of concept. Moreover, it goes in line with those gene mapping studies I was showing you with the interrelation between Crohn's disease, UC, and Ang-Spon. We now know this drug is approved for Crohn's disease, and we'll see whether or not in the phase 3 study, I believe, which is underway, whether this will be an effective treatment for ankylosing spondylitis. So the other area which has been really fascinating has been what do we do about our patients that are inadequate responders to anti-TNF agents? And as you know, there are studies with ustekinumab, secukinumab, showing that these drugs are very effective in psoriatic arthritis, but not so effective in the patients that are inadequate responders to TNF. They're effective, but less so than in those who have not seen an anti-TNF agent. And these data, I think, were really impressive. This is a tofacitinib study, 5 milligrams BID versus 10 milligrams BID. Primary endpoint was at month 3, as you can see here. And in this TNF inadequate responder population, 50% ACR20 is very impressive. And moreover, it didn't appear that it was dose-related. So the 5 milligram BID was similar to the 10 milligram BID dose. And the skin responses, however, were less impressive. And there was a dose difference at month 3, but less so at month 6. And you can see other measures. The HAQ-DI responded quite well. And also the other measures we have to look at, which are enthesitis and dactylitis, also saw a decline here. So this is very interesting. The reason I'm so interested in this is what mechanism is tofa hitting that the other agents aren't, and showing higher efficacy in TNF inadequate responders. And that's something that we're looking at very carefully right now, as are other groups. So I talked a lot about IL-23 mechanistically in the mouse model, and there are now data from a phase 2 study looking at guselkumab, which is an IL-19 antibody shown up here that, there's P40 and P19, IL-23 binds to 19, and ustekinumab binds to 35, which is shared between 12 and 23. So this agent was studied in a very well-designed phase 2 trial, and you can see that the ACR20 response is 58% here at week 24, which is an excellent response in psoriatic arthritis, but in league with what we've seen with anti-TNF agents and other agents that block 17. They also had excellent skin responses. This has resolved enthesitis and dactylitis. So in this early phase 2 study, it shows that this is an agent that does have efficacy. Not what we're seeing in psoriasis, though, but still we'll have to see what comes forth in the phase 3 data. So very exciting. So treatment horizons. You probably saw this study that was published. Again, Phil led this effort. Philip, the AB122, which is a dual domain antibody, which has it can interact with both IL-17 and TNF. It was designed with AbbVie laboratories. And what you can see here is that there were great concerns that there might have really much greater side effects, like combining TNF and IL-1 that we saw years ago. But interestingly enough, the efficacy was numerically greater with this dual variable domain antibody, but not statistically greater than adalimumab alone for psoriatic arthritis. But what's really encouraging is if you look, and this is really a study to look at adverse events, I think, because it's too small to show a difference in terms of the power. But you're going to see here that there was not a significant difference in adverse events. So what I take away from this is a mechanism that still has legs, if you will, in terms that it's not showing you a great increase in serious adverse events and maybe some design issues in terms of how these antibodies interact with 17 or TNF or different combinations, I think still have potential in SpA. So novel strategies, obviously we need better biomarkers. We need to stratify patients as to which agents are more likely to respond to. Early diagnosis of PSA, working with our derms and with our primary care docs, podiatrists. Stratification biomarkers are working very hard on that tough area, primarily because of the heterogeneity of patients with psoriatic arthritis, and also now with patients with SpA, because you've got the Axial SpA and ankylosing spondylitis, so it's challenging. I still think innate lymphocytes are an important target we should think about. A lot of us are looking at those. Combination therapies, dare I say it, maybe biologics in lower doses or spread out at different times, I think are still a possible strategy by typical antibodies. Lifestyle modifications, a huge area. We have a combined clinic with dermatology, and most of our patients are very heavy. I hate to say that, but it's really very hard. And we work with endocrinology and with diet and nutritionists. It's still a struggle to have patients be able to lose a significant amount of weight. And then the role of IL-17 receptor blockade because of adverse events remains unknown, but we'll have to see how that pans out. So just take-home points. I've tried to really drill home that the genetics and even the epigenetic data, which I didn't show you, are really underscoring the seminal paper of 73 and 74 in which Mullen Wright described a family of spondyloarthropathies. So their clinical observations are paying off and are being really confirmed by the biologic studies. Two, there is the distinction between AS and AxSpA is challenged. I do believe it's a continuum, but we have to understand a lot more about how they interrelate both in terms of transitions and in terms of the mechanisms. There's now very clear data. I did not show you that men and women, the mechanisms driving this disease in AS are very different. And that's fascinating, but needs additional work. Targeting IL-17 and maybe 23 is an effective strategy in PSA and AS. I didn't review all that data because it's out there and you know about it, but I think IL-23 is sort of the new target people are looking at. We'll see how that works.